Welcome back, everybody. This is the second session of the exercise, and in this part, we will talk about more of text data. Yes, text is everywhere. Where to wait, we post something on Facebook or on LinkedIn or blogs. So it's good to know how to work with text. Text is everywhere, and textual data actually has quite a lot of message. So we can extract a message from a different text, or we can just categorize documents based on some keywords. But today we are interested on the, for instance, Obama, Barack or Donald speech. Okay, so I have to just copy this and I take it to the exercise session. So it's going to be here. I call it Donald Trump. It's a txt file, yeah. And then I have to also have a file, Donald speech exercise or solution. I don't know what name to give anyway. So we can first read the file, right? Yeah. Open with. Always open with open and the name of the file. What is the file? Donald Trump.txt. And then let's also use the read mode, or we don't have to F, and then print F, maybe just like the first line, red line. So to know if everything is going right, so let's see. Because of this. Okay, now, not that, Donald speech, yes. As you can see, yeah, so we managed to, as you can see, we managed to print out the first line. So what's the question? First, we have to understand the question. The question I was asking you, what are the 10 most frequent words of Donald J. Trump? Yeah. So this can help you to solve different problems. It's not only for him. Once, if we do for Donald J. Trump, you can use the same for Barack or for Michelle Obama or whoever it could be. Okay, let's keep doing this. And now we can just do text cleaning, import regular expression. If you remember, last time we learned about the regular expression like r.find, actually match, if you remember, and search, find, all. I think it would be nice if I just, and another method you learned, substitute, and another, what is another? I think this is something I remember right now, so it's enough. Okay. Then maybe how about instead if we read, if you read something like this, you are reading everything. Let's see. Yeah, it's everything. But you can actually read lines. And this actually help you to read them line by line. Yeah, but this still has this line break. We don't like the line break. So we might say read split lines actually. Read and split lines. We read and split it at lines, as you can see. I think this is the step I'm interested, and I want to clean from here. Then I want to remove the characters that are not English characters. There's lots of way to remove. Okay, maybe I can just take you from the first, I think this is the place where it starts. Where did we? Yeah, as you can see, this up to here is one line. Up to here is one line. So it's a list of sentences or strings. So we have to remove the full stops. We have to remove the commas. We have to remove all the different symbols. Yeah. So to make that, since we have already lines here, first lines. Okay, store it like this. For line in lines, print line. I'll show you step by step. Yeah, so we managed to actually print this line by line. Just to make it very visible, we can print something like this. Something. Yes. Then you will see the gap in every step. Have you seen? Like after every line, yeah, after it starts with this, and then after that line. Yes, so now let's clean every line. For instance, if I'm not interested with the dot, what is this? Substitute anything which is not a word, that means capital W is non-characters, I think. So I want to replace it with just a space and lines. Let me try. Do you remember? Or, okay. Do you remember this? If I say A to Z, what do I mean? That means any character A to Z is any character A to Z uppercase, and it could be one or more, this. So now, for instead now, except this. Now, if I say this, except this and space, I am replacing it with just, that means if it's sometimes, yeah. I think let's try with this. So this is a complement in mathematics, so negation. So if something is not A to Z or A to Z as uppercase, or if it's not space, we are removing it or substitute that with an empty space. Let's see now what we get. I think we got an error. The reason why in return count.
Because you use lines, not line.
Oh, thank you. Thank you so much. Sometimes I don't see, and that silly mistake happen. As you can see now, this is clean. It doesn't have anything. Let's see. This is also just word characters. But let me show you this. Some problem somewhere. Will is okay, but I saw some this, for instance, this maybe it was per, I don't know, but this, so the apostrophe has been also removed. Have you seen? It is. Now it's just S. It's okay because we don't need this. at some point. So now it's really clean. At the same time, I want to change it to actually lower case here, lowercase, and save it as in, again, I can save it as in a line. I just modified it and print line. Let's see what we get. Yeah, it's really clean, as you can see. Oh, I'm happy with this. And now we can split this, just split like this and see what we get. Now we got, as you can see, just this kind of words. Yep. Now, actually, it's all about merging this together. Yeah, so to merge, we can say words. I can say something like that. By the way, we can merge two lists. For instance, if I have 1, 2, 3, and if I have 4, 5, 6, as you can see, we can just merge like this, yeah? So we can do concatenation. So what kind of concatenation can I do? Words, class, and then line. Now, this is not anymore actually a line because it has been changed to, but I can say list of words, and I can just say list of words, and now I'm just concatenating now and then. And let's see now, print words as one big chunk of words. Or oh, what happened? What was wrong? At what step did I make that? Strange. How? Okay, let me just figure out again. I had here lines, line actually, but let me just add the line here. Maybe if there's something I didn't see. Oh, what? Okay. Maybe I can use another trick. I don't know what happened there. I can just spread it here then, line. I will tell you if this works. I will just tell you what I'm doing. This the star sign, okay? Spread takes exactly one argument. Yes, it takes one argument. Yeah, that's true. Spread takes, append takes only one argument. Yeah, that's true. Yes, then I think why, how to merge different lists. Yeah, it's just straightforward, but why it didn't work? This, okay. Oh, yeah. Okay. Instead, how about if we say I want to have yeah, maybe the maximum what I can do another loop, word in line, and append one by one. So word is a word, a single word. If word W is just string for you, just change it to line. Yeah, I think the best way usually what you should do, just write the code what comes to your mind and then refactor it later. Print words. I was trying to just make a very clean code at the very beginning. So, I didn't understand where is it coming and why. But let me try to print here. What's here? A word is before this. Let's see what we have in there. Okay, yeah, so the problem is here. The line we are trying to print got something strange. So let's see what we have here. Print line. So, yeah. But I got, okay, I see. At somewhere I just removed it by mistake somewhere. Again, let's just line or words into line and just split at space. Yeah, that's somewhere it has been removed for some reason. Or you can just split it here, split there. So we are chaining it. And then I think even we don't have to go that far, then I may try the method I tried the first time. So now let's see. Yeah, now this is the words. Yeah, if you want to also just see the pretty print from pretty print, import pretty print, and let's see what is going to happen. Yes, it looks like this. Yeah, a very good word, but wind swept. Why these words comes together? So you have to have a closer look at what your data looks like. For me, it's politicians complaining and something like this. So now, how do you know the most frequent word? If you remember, I gave you the most frequent word from day 4. Do you remember this? We can make use of this to remove the most, the stop words. I can put it here or put it in a separate file. Why we remove, for instance, this, of, yeah, because everybody use this kind of auxiliary verbs, propositions, linking verbs, or whatsoever. Yeah. Then even we can do here when I'm adding, actually, I can go one step or maybe cleaned words, words without stop word, words without stop words. Okay, then I can say for word in words, if word not in stop. What was the name of this? Stop words. Words. And then again, we just put it here. Yeah, now you're a ninja of this use of a comprehensive list because it's really nice. Then print word without words. And if you want it to be print, then we will have words that have relevance, you know. Yeah, now as you can see, we got words that has some relevant meaning. Yeah. Okay, now we can just make Chief Justice. Now let's do this frequency table. Frequency table, freak table. By the way, do you remember how we create the frequency table in the other exercise here? Maybe here. I could go all the way down, yeah? So here, I can just copy here this and make use of this code for the text analysis or for, I think this is, the frequency table remains the same. Weights, instead of weights, I could change it to words without. So in this case, that means this can be a generic function. If it was a generic function now, I shouldn't change this kind of things. So let's change it here also as a generic function, and it can be used at any time. So what do I, actually we have a generic already. Oh, at some point, did I change it? Yeah, this, okay. Then I think I didn't have a generic also. Let's make a generic here. I call it Dave, find or calculate freak table, yeah? And then I just put it here, something like this. So I have to indent this. Then this has to take a list because most of the time work with list. List is a very powerful data structure. I think this is the place where we need to change it. The rest is just the same. Okay, great. And then we return here in this case because I was interested in more of the first one, but now if I want the 10 most, the something the 10 most, for instance, if I want the 10 most, so it's just already by default 10. But now I may just return sorted. And then what's the sorted value? Sorted value. But it doesn't look like return. Return. Oh, today I don't know how to write return. Sorted value. And then I want to slice up to n. Yeah, but what is this? Yeah, we are sorting. Great. Yeah, this is a very good function that can be used for anything. Now we developed another very good function. Yeah. Okay, so I go to here and I destroy this because I don't want it. Instead, I just call the function print find freak table and word, because now what you need is just passing the list. And let's see now our frequency table. What does it look like? I have to just do this. Oh yeah, America 17 times. Yeah, just to see, just to do that, print. Yes, America 17 times, people. Yes, he was saying America first. Yes, and the other second. Okay, America 17, people 10, American. And now, as you can see, America, American in language processing. This will be almost a kind of one word, but a nation every today, one new great back. Yes. Yeah, an aeroplane is passing by, so there might be a noise. Let's just give it some time. How about if we are interested to now, it's so easily we can check, we can compare, because we just did already a function that calculates everyone's thingy. So let's just do for Donald. I mean, I think for some reason, just Donald came to my mind, not this Obama. So let's just copy Obama's. And how does Obama's sound like? Okay, now I just do the same. Barack Obama. I hope they don't mind for using their speech for learning purpose. Yep, I hope they don't. Okay, then what I should do, because I have to go to this text now, the problem, we gave it a very strange name here, Donald speech exercise. Now, this is not a very good file name. I call it a speech text. I just call it, and it could be used for Barack and for whatsoever. And now again, this, as you can see, this is not a good function because it's not a function. Let's change this function because it just fetch only Donald. So I can call it maybe read file, and it should take a file name. And then we have to indent this. Yep. Then instead of Donald, we have to pass file. And then as you can see, now we don't have to also print words without, no, but now when we pass words without stop words, how do we create this words? By the way, I'm not returning anything from here, so I have to return the words. And then to get the words, I have to call the name of the file. Yes. Donald words. Donald words can be read a file, and then we pass the name of the file. By now, I don't know. So I have to copy this. Rename. Then I can just put it here. And then Barack works. Barack works. And I think Barack Obama. Yeah. Yes. So, and again, now we can just do the same. Instead of like this, you just pass Donald words. Let's try with one, because since we made lots of a change, we may have no such a file or a directory. Yeah, that's what you should. Donald speech. Oh yeah, because we changed the name of the file is speech exercise. A speech text could be just speech text exercise.py. What's the name now? And then again, I have to change it still. Speech text exercise. Yes. Then now when we run this, yeah, as you can see, still our function works, but this is for Donald, so I have to give it a tag. If you don't give it a tag, you don't know from where it's coming from. Speech takers, then what I should say when I'm reading Donald speech. Yeah, and then I can repeat the same for Barack Obama. And just here, Barack or Obama. I think Obama. Consistency, Obama. Obama, word is Obama, word is, yeah, it's okay. Well, this object has an attribute right. What is happening? So we have to line 34. Line 176. What happened? It seems so is this file because the Donald G Trump was working. There's no D here. Of course, there was no red at the very beginning too. But let's see again. Yeah, it's we're getting some value, but I think that's from a previous data. Line 53, p-print, okay. In p-print object, I thought we had p-print from p-print import p-print. And I don't know what's happening here.
But it said line 53. Do we have line 53?
50, let me, yes, wait, I have seen something. What, really? It seems that p-print doesn't support multiple. I'll check. Oh, sorry, so p-print doesn't support additional argument, so we can just handle this by writing print Donald, and or for this one also we have to remove this one. We have to remove this, and we can write print or print and Barack or Obama. Okay, now it should work again. Obama words not defined. Obama, well, yeah, it has been commented out. Yes, so, but why? Because I thought we have cleaned the, and everything. Why we see the? By the way, the most frequent word in the English language is the and something. But for some reason, as you can see, we didn't remove the stop words in the yeah, because here, as you can see, instead of returning words, this one, I return just the words. So that was not right. So now I can get, yeah. Okay, so as you can see, Obama was saying as unit times, as a nation, a new America. So every must today, people, less word. And how about Donald was saying something, but now you can, now our function is so powerful. I can see the 50 words, the 50 most by just passing parameters, because now it takes parameters, our frequency table. Yeah, let's see. As you can see, forward, yeah, let's move forward. History, hope, short, say across many, care, jobs, economy, ideals, carry prosperity, oath, American power, weather meet, greater, whatsoever. So let's see the others. Small Washington, transferring Obama, then get face years, national foreign, allegiance, good millions. Is there any? Yeah. So anyway, what is this? We just use Python. We didn't use any kind of package to do this, but there are already lots of package like NLK that allow us to do lots of natural language processing. Natural language processing. What does that mean? Natural language processing is actually a process of understanding human language, understanding human language, and plus actually generation of human language. Yes, generate human language. So it's a combination of linguistic and machine learning and artificial intelligence. So it's actually an advanced topic, but there are lots of packages like text blog, NLTK, and SPACY that allow us to process text even without understanding much about language. So we have to stop here. And if you have any question, I would like to answer. But in terms of this text exercise, this is my part. But if you want to go further, how about if you just study the difference between Melina and Michelle Obama's speech between. Is there any similarity? And to study that similarity, you have to use one method, they call it the Jacquard similarity. So you have to apply this Jacquard similarity, you have to read about it, and you have to make use of. So this similarity or distance, there are different distances, ML distances, machine learning distances. That I just came up with something. I think there are more than 4, but as you can see, Hamming distance, Euclidean distance, Manhattan distance, and Minkowski or Vesky distance, and that's the other distance I told. Cosine distance, there is no cosine distance here, and the Jacquard distance. Those are some of the distances that can be used to find some similarity and differences, distance. Okay, I think I am done with today's lesson, so I have to stop the recording if you don't mind. Okay, then I will also just give you a NumPy and Matplotlib and Pandas video. It will be uploaded on the Coding for All YouTube channel there, and then yeah, you will be notified. So just subscribe for it, then you will be notified. You don't have to wait for me until I notify you here. Okay, let's stop it here.